Weird water. Water can take three different forms: liquid water, a gas called water vapor, and solid ice. Water is amazing stuff, and it does some amazing things. It flows, it sparkles like diamonds, and it seems to appear and disappear like magic. These are all large-scale observations of water's appearance that we can make with the human eye. We can also think about water and all substances on another scale that we cannot usually see, the molecular scale. Molecules are too tiny to see, but they are very important. Water is made of molecules, and so is almost everything else on Earth. The appearance of water is determined by the way the water molecules are moving. You might think of water as a liquid, but water can actually exist in three different phases: liquid water, solid ice, and a gas called water vapor. No matter what phase water is in, the water is still made of the same molecules. They just move differently. In the solid phase, known as ice, water molecules are tightly packed and can move only in place. In the liquid phase, water molecules have greater freedom of movement. They're able to move around and flow from one place to another. However, they still stick together, which is why liquid water forms little beads on a car windshield when it rains. In the gas phase, known as water vapor, water molecules move around a lot and they don't stay right next to each other at all. Water vapor doesn't stay where you put it. To learn more about some of the unusual ways water behaves in its different phases, choose one of the chapters that follow. Flash floods in slot canyons. Slot canyons like this one are carved by flash floods. Imagine hiking in Antelope Canyon, a very tall, narrow slot canyon in the Arizona desert. The walls of Antelope Canyon are steep and curving and made of deep red rock. The canyon looks as if it was carved by a flowing river, but the floor of the canyon is bone dry. What formed Antelope Canyon? If you're very unlucky, you might find out firsthand. The canyon was formed by flash floods. Even in the desert, there is water vapor in the air, molecules of water in the gas phase. These molecules have a lot of freedom of movement and can move apart from each other, so water vapor is invisible. Even though you can't see it, the water vapor is still there. When conditions are right, hot air forces water vapor upward, high above the desert floor, where temperatures are cooler. As the water vapor cools, it changes phase and condenses into droplets of liquid water. These droplets gather to form huge storm clouds. Soon, big drops of rain fall on the desert. The hard, dry desert ground can't absorb all the water, so the water flows quickly across the desert floor, becoming a flash flood. Deserts may be dry, but certain conditions can lead them to have flash floods. Rainwater flows across the ground because the rainwater is liquid. In the liquid phase, water molecules have enough freedom of movement that they can flow and move together. Liquid water also flows into any cracks in the ground. As the water flows through the cracks, it washes away bits of rock, making the cracks wider and wider. Over millions of years, one flash flood after another widens the crack more and more and digs it deeper and deeper, carving a slot canyon. Flash floods happen quickly. Inside slot canyons, flash floods are especially dangerous. They can quickly fill the whole canyon with water, drowning anyone caught inside. So during a flash flood, water rushes through a canyon. Glacier caves of Iceland. Streams of liquid water flow underneath glacier caves, heated by the rock below. In a country named Iceland, you might expect to find glaciers, huge sheets of ice that may be thousands of feet thick and stretch for miles. Iceland does have glaciers, lots of them, but this country is also known for its fiery volcanoes. These volcanoes often erupt, sending out hot lava and ash. Hot volcanic rock lies very close to the surface in Iceland. So Iceland is known for its volcanoes as well as its glaciers. The combination of glaciers and hot rock creates some of Iceland's most spectacular features: glacier caves. Iceland's glacier caves form when ice at the bottom of a glacier comes into contact with volcanically heated rock below. The heat of the rock causes some of the ice to melt into liquid water and flow downhill, creating tunnels under the glacier. The cave walls and the water flowing through the center are all made of water molecules, and it's the behavior of water molecules that makes these wonders possible. In the ice walls of the cave, the water molecules have very little freedom of movement. Since the molecules of water are held in place, the ice is rigid and keeps its shape. These hard, shiny walls of ice sparkle in the light from visitors' flashlights. In spots where this ice meets hot rock, the ice changes phase. As the solid ice melts into liquid water, its molecules gain more freedom of movement to move around. The molecules of liquid water become free to slide around each other. Because of what's happening on the molecular level, the liquid water is able to flow, forming streams and cutting tunnels through the ice. So ice caves form when the ice in glaciers is heated by volcanic rocks underneath. Some of the ice changes phase into liquid water and flows away, leaving a cave. Frozen Niagara Falls. For the water in Niagara Falls to freeze, the weather must be very cold. More than 283,900 liters, or 75,000 gallons, of water flow over Niagara Falls every second. A gallon of water is made up of trillions and trillions of molecules, so that's unimaginable, a number of water molecules flowing over the falls. It's the molecules' freedom of movement that makes this spectacle possible. The water in the falls is liquid, so the molecules are free to move around each other and flow. However, they don't fly apart the way molecules of gas do. Because of this, all that water stays in the river channel and falls down to fill the basin at the bottom of the falls. Niagara Falls lies on the border between the U.S. and Canada. That far north, winters are often extremely cold. The cold weather causes a phase change. Niagara Falls freezes, not completely, but large parts of it. The spectacle of the partially frozen falls is thanks to the behavior of water molecules. When it gets cold enough, the water changes phase from liquid to solid. The molecules lose some of their freedom of movement, becoming stuck in place. They still move back and forth a little, but they can't move around each other. Because of what's happening on the molecular scale, the flowing liquid freezes into solid ice. It forms huge icicles, ice columns, and a shelf of ice at the base of the falls. So during cold winters, Niagara Falls partially freezes. The frozen falls may look like sculpted rock, but they are still made of water molecules. As warmer weather arrives, the ice melts into liquid water and the fall flows freely again. About 283,900 liters, or about 75,000 gallons, of liquid water flow over Niagara Falls every second.